Hello. So I think my screen is visible. So let me open the sheet which we are solving. So today we will solve this particular problem, palindromic substrings. Let's open this. Okay. So the problem says, so I have solved this problem in February 2024. Okay, so let's read out the problem. So given an integer s, return the number of palindromic substrings in it. A string is a palindrome when it reads same as backwards as forward. Okay, a substring is a continuous sequence of characters within the string. Okay, so basically we are given a string and we need to check, we need to find the substring of it which are palindromes. Okay, so here A, B, and C individually are palindromes. In this particular string, the substrings are double A, double A, triple A. So these are the palindromes. Okay, so I think before doing this problem, you should approach this problem, longest palindromic substring. So we're finding longest palindromic substring. So we will use the similar approach here. So what we will do, we will for every index we will expand our, we will put two pointers on an index and we will expand that pointers, means we will expand that pointers and will count the number of the substrings in that way. So how we can do that? Mm, let's say n is the length of the string. For every position in the string, for the odd substring we will start from the means the our this pointer and this pointer, these are two different pointer, will be initiated from a single position in the case of odd length substrings, and we will pass our substring. And in the case of even substrings, what we will do, means the even length substring, this will be giving us odd length substring. This will give us even length substring. Here we will pass this I and I plus 1 and our string. So let's initialize our count. Means the count of the substring, which will be initially 0, and we will return that count at the last. Suppose this function returns the palindromes of the odd length, and this returns the palindrome of the even length. Okay, so let's implement this function util. So this will be our I pointer, this will be j pointer. So in the for the case of odd length string, have we will have both these pointers as same, and in the case of even length we will start, this will be adjacent pointers. So we will pass this our string. int palindrome count. We will initially palindrome count will be 0. At the end we will be returning this palindrome count. So we will shift our left pointer to the left side, the ith pointer, and jth pointer to the right side. So while I is greater than 0 and j is smaller than string dot length, what we will do, we will compare if our character at ith position is equal to the character at jth position, then we can say this is a valid palindrome. So we will increment our palindromic count. So I think, and then what we can do, we can look for other strings. For example, I and j are at a initially. So both are at I and j. We will compare if I character at I equals to character at j. So this will be true because a is present at both position. And suppose in the left of a we have a b and a b. So then in this case, what we will do, we will decrement our I and increment our j, and again compare whether this is a valid palindrome or not. This is a valid palindrome. Suppose here is C and here is D. Then our I comes here and J comes here. So these are not equal. In that case, we will break our loop. Means if these are not equal, in that case, we can break the loop. Okay. What we can do is we can check here itself. I think this will be sufficient. Wait a second. Okay, so this is working. Okay, so I think we can move to the next question. Uh, so the problem is decode ways, and the problem says you have intercepted a secret message encoded as a string of numbers. The message is decoded via following mapping. Okay, means a one is mapped with A and 26 is mapped with the Z. So, however, while decoding the message, you realize that there are many different ways you can decode the message because some codes are contained in other codes. Means 2 and 5 versus 25. Example, this code can be written into this code. Basically, this is we are splitting this into this. This means this is A, this is J, this is F, and Also, what we can do, we can group these two ones together, 11, 10, 6. Then this becomes this string. So means we can group, means we can make a number into different strings. Note be there may be strings that are impossible to decide. Okay. This grouping is invalid because we will not allow invalid is a only 6 is valid. Okay, so we will not allow 0 at the starting. Okay, so we need to return total number of ways in which we can decode. Suppose here we have 1 and 2. We have two ways. We can decode it at AB or we can decode it as L. Okay. Okay, so we need to find number of ways. So we need a utility function which will return our answer. Let's say this function returns our answer, and in this string we start from this position idx, which will be 0, means from 0th index. Let's pass s the string and length of the string. What we can do is we can make splits into this string, means dynamically, and we will only make the valid splits, means we will not consider splits which start from the 0th position. Okay, if our index becomes this, we can return 0. Okay. We should return 1 here, I think, because that means we have found a way. Okay, means we have encoded the whole string. Otherwise, suppose if we have what we can do, we can take a substring of one length and two length, means only as one length and two length values are present against the character, so we can consider only one length and two length strings. Okay, so what we can do is we can check first, means for the invalid case, means where we have 0 at this position, means the z, 0 as the prefix. So what we can do, if our s dot character at index, if it's 0, so we can return 0, that no way is possible, because in example we are given that there may be impossible strings to decode. Suppose we have this string, so we are not allowed to decode this string into something because it's starting from 0. And if it's not starting from 0, what we will do, we will first find the, so it's our current character. Okay, So we can take a string of one length. So now string of one length will be valid. So what we can do, we can suppose call our util function, and the string of the one length will be, means this is a way because a string of one length is valid. So we can return int ways as the util, and we can increment our index 1 and s, we will pass s and n. So of length 1, so this will be of length 1 for the character, means if we are choosing one character only. So it will be possible because we have eliminated the this case. Now what we can do, we can consider string of length 2. So let's say if our idx plus 1 means, if means our current position is valid, we know from this, but our the position current to next also need to be valid. So if it's a valid position, then what we can do, we can check if our int value of this will be integer dot parse int, means we need to parse s dot substring starting from index and ending at index plus 2. If this value is smaller than equal to 26, then it's a valid case, and we can add to our ways and increment our index by 2, and at the end we can return the ways. Okay, and for this we need to return 1 because suppose this function reaches means using this function, suppose we see that all the characters are valid. So at the end we need to return 1, that it's a thumbs up that this is a valid string, means this way is correct. So that is why we are returning 1 here. Let's see what can be the length of so our length of the string will be minimum 1. So it may fail in the condition where the length can be 0. So in that condition we cannot have any way, so we don't have that situation here. So I think this should work. Let's see if this works. Okay. Okay, so it is returning the, okay, for this test case is giving output 0 because we have 0 at the starting, that is why. So now I think we need to memorize it. So only this index is changing, means one variable is changing, we can create one DDP. Okay. So we can put the condition here if we have already calculated, means we are filling dp with the -1 and passing dp variable in here in our function call, wherever we are calling the function. and we can check if we have already solved this problem for this particular index. Means if the value is not -1, we can return the dp answer stored in our dp, and at the end we can add that answer to our dp. So I think memorization will work this way. Okay, so we can submit this. Let's see if this works. Okay, it's working. So let's see if previous submission was same. So we have a TLE case also. Okay. I think our current solution is not messy. It's a bit cleaner. Okay. So we can move to the coin change problem. Uh, Summation was in 22 last submission. Okay, so the problem says you are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Okay, this is total amount of money. These are the coins. Means this is a 1 rupee coin. This is a 2. This is a 5 rupee coin. Okay, so we have this coin. So return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, return -1. Okay, you may assume that you have a infinite number of each kind of coin. Okay, so we can use each coin multiple number of times. So basically, the problem is saying कि we can use this coin. Okay, you can use. So we have three ways. Okay, okay, okay. Only zero way. Coins representing coins of different denominations and an integer amount representing the total amount of money. Return the fewest number of coins that you need to made up that amount. Okay, the minimum number of coins means we need to make. Means minimum number of coin we need to use to make this value. Okay. Okay, so to use minimum coins, what we can do is we can use the coins with the greater value first in our combination. And whenever we use a coin, we can increment a count that we have used a coin. Okay, so what we can do, we can sort our coins array so that we can take only coins with the maximum value. Okay, so now coins with the maximum value are at the end of our array. So we can do one thing, we can put the coins in the front of our array, means we can sort array in descending size also. Okay, descending, that will be like b minus a. Okay, I think this will work. Now we can call the function return min coins, and the length of the coins is, we also need that length, coins dot length. We can pass the length, the index on which we are currently. We are at the index 0, means the at the maximum coin, and the coins array and the length of the, and also the amount which we need to make. Okay. Okay, we have passed the amount which we need to make and the index of the coins and the coins array and the size of the coins array. Let's, okay, so let's set the base condition. If let's say our amount becomes 0, what we can say that we have made up the coins, so we can return 0, that the value have already becomes 0, means the we have already made up the value, means we will be, whenever we will be picking up a coin, we will be decreasing that amount from this, that coin's value from this amount. And if our index becomes greater than or equal to n, we can also return 0, that we have reached the end basically. Okay, if we have reached the end and the amount is not 0, what we can say is we haven't found the way to make amount, so we need to return something else here. We need to take a look here also. So let's first try to implement the main logic. So we can take a coin. Let's say we are at this coin, and if this coin's value is smaller than or equal to the current amount, then only we can take this coin. Okay, and also it's not necessary that we take a coin. Means taking a coin in future can cause us a issue. So we can skip the coin also. So how we can skip a coin? We can, increment the index without making change into any our amount, and we can move on further. Okay, and if we want to take a coin, then coin's value should be greater than or smaller than equal to amount. And if we take a coin, that means we have we need to add one because we have taken one coin. So then we can call our function. We can increment the index, and this much amount we need to reduce. That we have taken this coin and now we are reducing it from the amount. Okay. So now this is the value which we are getting after taking. So what we can do, we can make our skip value as the maximum of uh, skip itself and this value which we are getting after taking. So we don't need to initialize other variable. Okay, and at the end we can return this skip value. But the issue here is it's possible that we we don't get a coin, means we have transversed our whole array and our amount is still not equal to zero. In that case, we need to return something else here. Okay, if our amount becomes zero, we can return zero. Okay, if our index is greater than equal to zero, greater than equal to n, this means it's greater but amount is not zero. Means this is not a way. So we need to return something here. Okay. We can return something else here so that we can identify that this particular call is not a way to find the coin. Okay. We need minimum value here, not maximum. We need to find minimum number of coins. Okay, suppose what constraints we have. The value of coin can be this, means the it can be within the integer range. Okay, and amount can be this. Okay, Means total amount is only 10 raised to the power 4. And suppose if amount is 10 raised to the power 4, in the worst case, if all the coins are 1, then we need to pick the 10 raised to the power 4 coins. Okay, means our number of maximum number of coins will not exceed 10 raised to the power 4. Okay, this will be our maximum number of the coins. Basically, this is we are storing the maximum number of coins. Suppose we return something like integer dot max value by 2 because we will suppose this call returns maximum value and we add 1 to the maximum value, then this value will overflow. So what we can now do is, if our this skip value becomes greater than or equal to this value, greater we are adding because we can add 1 to it also here, that's why it can become greater also. In that case, this will be not a valid answer. Means we can say that both of our calls have returned this particular call in which we are taking the coin, and this particular call in which we are skipping, both are leading to the invalid answer. So we can return 0 in that case, that there is no way. This is taking a coin, this is keeping a coin. Let's see if this is working or not. Okay, we need to return our int value here. Okay, we can't sort array like this. Okay. So what we can do? I think we can do something like this or not. Okay. Let's see how we can sort the arrays. Arrays dot sort. Why this is not working? B minus. Do we need to do something like this? No suitable method found for arrays dot sort. Okay. Mm, this sorts array in descending order method with a custom operator. Okay, why it's not working here then? Let's not pass this comparator and let it get sorted in the ascending order. Then what we will do, we will pass the last index here. So index it will be this, and if our index becomes smaller than 0, and we need to decrement the index in that case. Means now what we are doing, we are starting from the last. Okay, code is running, but we are not getting correct output. We are getting 0 for every case. Okay, okay. I think here we are doing mistake. We need to find the minimum number of coins to make that amount. Okay. Okay, suppose we have this array and we are starting from this index 5 and our amount is 11 initially. Okay, so here we do have a one condition also, I think, that is we can use a coin infinite number of times. So what we can do, while skipping a coin we will keep our index same, means we can reuse this index. Okay. Okay, we are skipping an index again and again. Okay, so what we can do in this call, we can do means while taking a coin we will not increment its index, means that will mean that we are retaking it, reconsidering it, because here only we are making change in amount, so our call then can end here. Okay, working for this case, and for this case the output is 1 but is okay, so we need to return -1 in the case where we cannot make that amount up. Okay, means we need to return -1 here. Wait a second, why we are getting 1 here? We have coin 2. So okay, yes, our index is not smaller than 0. If we skip this part we get 0. Okay, after skipping this we will get, wait a second, if we skip this means if we increment our index then we get the maximum value, means this value here. Okay, if we consider this means this value 2 is smaller than our amount, so what we can do, we can add 1, skip is this value 1 plus this call will go to the same index, means here itself an amount will be 1 now. Okay, amount is 1, we can move to the previous index. This will again give us this. Okay, we check if this is smaller than amount or not. No, it's not smaller. This is greater than or equal. Okay, this will return 0 to this given. Okay, we can avoid this condition and put a check here itself, that if it's if our answer is greater than equal to integer dot max value by 2, in that case we can return -1, otherwise we can return our answer. So I think this change we can make, because here what we were doing, we were uh, giving a 0, means 0 for this call, where the answer is not existing, so that 0 was causing the issue, that was getting up add up here. Okay, I think this solution will work if we memorize it. So what we can do is, we can see that our index value and our amount value are changing, so we have two variables changing, so we need to create two ddp. So we can create dp new int n and amount plus 1, and we will initialize our dp with 0. Okay, we have initialized the dp. We can pass dp into our function calls. Okay, and we will check if for this particular index, if this much amount is left, do we have calculated this sub problem or not. So if after these base conditions, checking these base conditions, we will check if dp of idx and amount for this particular values of variables, if we have some value present other than -1, then we can return that value. Otherwise, if that value is not present, we will calculate that value, and after calculating that value, we can store it into dp, so we can use it in future calls. Okay, we have some compilation error. We need to define the type here also. Okay, let's submit this. Okay, so I think we have solved this also. So I think three problems are okay for today. We can try to complete this tomorrow, DP part. Okay.